Okay, now, so the mouse is much more responsive because I've connected it using USB cable. Hardwiring is always good. Early on, I had it connected through Bluetooth, actually, so there was some lag there. Okay, let's get to business, Ashley. So we are going to solve this assignment. We aren't going to completely solve it. I'm gonna let you do that. But again, I will give you some information on like how to approach this assignment problem. So we have to write a program to blink an LED. So we just need the program here. I don't want any execution here, but like what we'll do is like I will try to bring in an LED and see like how you can use that here. And early on we started off with serial communication. We will use the same and then like slowly do other things. Now I wanted to also use a pin and want to use that as an output, and I wanted to turn it on and off. So I'm going to just keep it as is, actually, like although I'm not going to use serial communication right now, I'm just going to write a program to blink an LED. Okay, so I'm going to use pin mode to set up an internal. So there's a internal LED. So this is that LED, which is connected to pin 13 and ground. So this is kind of a built-in LED that you can use for testing your board, actually. So you can turn it on and off, and like you can see that working actually. What I'm gonna do is I'm just going to use that pin and set that as output. And what I'm going to do is I'm going to digital write pin 13. So you'll have to specify which pin it is, and then you will have to say hi. And let's see whether that turns on actually. So we'll start simulation. I want to get rid of that, or maybe we'll do that. So it's on, the LED is on. So let me turn it off. So pin, I will stop simulation. It is on already, but like again, off, it's not going to be on at all actually. So that is what is going to happen here. But let's say I wanted to set a delay. So there is something called a delay function. We talked about this already. So the delay is going to be in milliseconds. So I'm going to say delay. And let me delay for like a second. And then what I wanted to do is I'm going to digitally, right, my apologies, 13 to low. And I will do another delay. And just start simulation. Oh, my bad. So again, it is case sensitive. It's delay, and one more thing is it's not digital, it's digital. Okay, let's run that. So that's how the error appears. Okay, still we have something. Did I do something? Oh, digital. So this is how an error appears. So there not be IDE, again, like you will have something like this. So let's program. Okay, so what happens is if you see the LED blinks, it turns on and stays on for like 8,000 milliseconds for a second, and then it turns off and it stays off for 1,000 milliseconds. So if I wanted to increase the speed, 1/10 of the speed right now, or the frequency right now, I will stop simulation. Then I will run it. So maybe we don't see that much here. It is turning up a little bit. Maybe to make it obvious, let's do maybe 300. Again, stop simulation. 300, 300. Let's get started. So that is 300 milliseconds. So you can turn it off, and this is how you kind of blink an LED. So this will be like a basic setup. So what we'll do is we'll also, like, instead of blinking these, we can connect a LED on the breadboard actually, and then see what happens. Instead of all, I want to bring in a resistor. I will bring a resistor and set it up right there, and then LED. I'll bring that anode. It is going to be connected like that, and let me connect it to the ground. And then I want to connect, maybe instead of pin 13, let me use pin 2. Why not? And in my program, I'll have to change that. So I'm not using pin 13 now. I'm using pin 2. And I'm so going to set pin 2 as high, pin 2, and I would say some value between 200 and 400 should be sufficient. So let me say 200. And let's get started. So it blinks at 300 milliseconds. So stop. Maybe let's do 2 seconds. And turns on for 2 seconds and turns off. Turns on, 2 seconds, turns off for 2 seconds. Okay, so that is LED. So a digital pin out, we are using that. Okay, that's good. And now let's use the serial communication. So let's say if I wanted to send some information and control this LED, how do we do that? Okay, so before that, I wanted to see like what I receive. So if I send one here, like what do I receive? So let's say I wanted to send one here and I want to read it and I wanted to print it. Okay, so for now I'm going to comment this out. So how do you comment it? So you use this for multi-line comment. I'm not going to use that code right now. And so here in serial communication, I have established my communication here, and here I am printing like whatever is available. But now if I wanted to print whatever I've received, actually I will say serial print. Maybe I don't want to print this one for now actually, so I will use a single line comment. I want to, instead of, I will do read. Maybe I will do serial print on. And serial read. So what I'm going to do is I'm going to read what is being sent by me from this serial monitor and then print that back. Let's send some numbers and see like what happens. Okay, so I'm going to start. Okay, so it is reading -1. Maybe I need to set a delay so that like I can see like what is actually happening. So when you don't have anything, it's going to be again. We'll also use another code actually that is so that like it is a good practice. So you're reading -1 because you don't have anything. You might have any chunk there actually in the serial buffer. So if serial dot available and I'll close that. and then only when it is available, please send me something, or please send me what it is there, and I'm going to read that and I'll send it. And then I will also use a delay so that like I'm not spitting up some value. Delay maybe a second should be sufficient. Okay, only when it is available. Okay, it'll read it and then it'll send it across actually. So let me run the simulation. I'll clear the output. I don't want anything. So right now I don't have any junk here. Okay, so let me send one, and I'm receiving 49. 50? Does that make sense? And I was sending E and S and F. I'm reading some other number though. So what are those numbers? So to understand that, let's go and check ASCII. So this is the ASCII table. Okay. So here is an ASCII table. So let's see what we receive. So I'm going to use that and that. And so if I send one, where's one? Okay, one, I'm getting 49, right? So it is actually sending in the decimal representation of that. It's not the actual number 1. If I send A, 97, and I could also send some other, let's say a capital, or let's say the uppercase A, 65. So this is what happens. So like when you use serial communication, it communicates in ASCII. It doesn't use the normal communication actually. So if I wanted to check a condition and like print accordingly, I could use a function here to execute something like if it was like say I can send 1 and check whether it is 49 and then I can do it like that. If not, what I can do is there's also another function. So for now I'll get rid of this. And sorry about that. Okay, so now what I'm going to do is instead of like I'll clear the output, instead of using this to turn on and turn off, I just wanted to convert it back into integer, or like say anything actually. So integer or like character or something like that. Here in this case we are just trying to convert that back into integer. So we are going to use a different function. So instead of using serial read, what I'll do is I will first I'll have to stop simulation, and for now I'm going to get rid of this and make sure you don't have anything. Okay, so what I'm going to do now is if serial is available, then I have to read. Instead of using digital read, I'm going to use something, not digital read, serial read. I'm going to use the read string function. And then I will use an attribute of that function called toInt. So what this toInt does is it converts that into an integer. So that's what this does. So I will use that, and I can print this actually. So serial dot println. So that is going to be printed. For now, like I don't want this again. Maybe we'll try this and then like remove it back. I'm going to comment that out. It's not going to be executed. So I will do that and I will run it. So it is going to read it as a string, and then like convert it back into an integer and like print that. What do I do? Okay, so okay, here. Okay, we are missing another brace actually, and now serial monitor. I'm going to send 1. So if I send 1, actually 49 ASCII will be sent to the Arduino, and Arduino will read that and send it back, and that's when we use serial read function. But if I send 1 now, it returns 1. 2, it returns 2. So it takes the string and it converts into an integer and sends it back. So now I wanted to use this to control my LED. Okay, so let's do that now. So I'm going to stop simulation. And now I will add the brace here. And I'll use another condition. If, or probably, I don't want it to print it anymore. If my string is 1, so equal to 1, that is equal to, just an equal to sign is an assignment operator, which means it will assign 1 to that particular function. But here we use equal to 1, then I am going to set that as high, else maybe I will add a delay here as well. Else set it low. Okay, so if it is available, if I send some number, it'll allow this function to execute, or this statement block, and within that statement block we have an if statement. So if I send 1, then this will be executed, it'll become high. If not, it'll be low. So every time I send 1, it'll be high. If not, it'll be low. Okay, so I'm going to move here and let me send, okay, start simulation, and I'll clear output. I'm going to send 1. Let's see what happens. So it turns on, and if I set something else, 2, it'll turn off. If I send 3, 4, doesn't matter. But if I send 1, it'll turn on. So that is how you use an if statement to turn on and turn off a light with serial communication. So you're controlling during execution. You just have to copy this, and if I wanted to run this on my Arduino Uno, so let me do that. So right now I'm just like say unplugging I'm connecting Arduino Uno to Arduino Uno to my computer. I'm bringing in Arduino IDE. Just give me a second. And here is my Arduino IDE. It's opening on the other screen. Let me bring it in actually. Here. So this is my Arduino IDE. So once you execute it here, you can just copy that and paste it here. So now once this is done, what I will do is, so here first make sure, yes, my Arduino board is connected. and Arduino board is selected, so no worries there. And now I'm going to verify. So that is good. So it'll ask you to save it, and once you save it, the sketch is complete. No error, so that's good. Done compiling. If I wanted to upload it, I'll just use upload. It is uploading, and it is uploaded. Yes, and for now I'm not going to show you. I have not set up my camera to show the execution here, but again you can use just say send information, same as before, to turn on and turn off the light. So that is how you execute, or say if you have a program, you can just paste it here once you're done confirming what is happening here, and then wire up your circuit, and then you can connect your Arduino using the USB cable and then upload your program. And that's how you do it on a real board. So that should wind up these two questions. And there is another question. I'm going to let you do that because in this case we are using a switch statement, so you will have to send numbers from 0 to 7. And when you send some numbers, say you can use 3 LEDs, and those LEDs have to be lit according to what digital or what integer you send. 0 should send 000, so this is a decimal to binary conversion program, so you will have to write that. So this is how you will wire your network. So you need 3 LEDs. So these 3 LEDs will be connected in this fashion. So first thing is you will initialize your serial begin and your serial communication with serial begin, and then you will have pin mode. You will have to set these 3 pins. You can use any of these pins into output, and then in the loop you will have to read it using the same function we showed here, right here, and then we will write based on the switch statement. So to see how switch statement works, we'll go here. So here instead of switch variable, this variable will be the variable what will be coming here. Again, we'll not be using this condition, so it is not a condition, it is just a variable. So this can be anything from 1 or 0 to 7. So you can have case 0, case 1, likewise up to case 7, and then you can execute it. Shall we try that here maybe? Why don't we use switch statement here and see what happens? So instead of this, I'm going to use switch, and then I'm going to define my cases. So maybe I'll get rid of this delay. So if I, so case 0, if I send 0, then this is going to be executed. You know what, it'll be counterintuitive. So let's do 1 and case 0. So which means if I send 1, my light will turn on, and if I send 0, my light will turn off. And the most important thing here is the break statement. So once you execute that, you just break. So I'm going to run this simulation. Do we have errors, or what did we do? Maybe I have more void loop. Let me see. So this is for this, a void loop. Then we have, oh, if, yeah, for if we need to have one. And this is for that. Maybe I will add another one. So I think now it should be okay. Okay, so let me open up my serial monitor. Let me drag this here. So if I send 1, it should turn on. If I send 0, it should turn off. So 1, it turns on. And if I send 0, it turns off. 1 on. Okay, let me do another case of default. Maybe I'll stop. So instead of case 0, if I say default, in this case it'll turn off only when I send 0. So if I have this as a default case, so only if I send 1 it'll turn on, but if I send any other number it's going to be low. Okay, so let's run this again. Okay. Default case should be okay. It was not declared. That is really weird. Oh. Spelling, like we'll have to be really careful with that. Even a small mistake will change things before default. Oh, sorry, this is not case default. My bad. Okay, so it just started. Okay, so when you say default, it's not case actually. So that was bad about that code. So if you send 1, it's going to turn on. If I send 0, turn off. Any number, turn off. So if I send anything other than that, it'll turn off actually. But like if I send 1, that's the only case it'll turn on. So that is how you use a switch statement, but in the assignment problem number 5, you will use 3 LEDs to execute or like convert digital or convert decimal to binary. So that's what you'll be doing. Okay, so that is it, and in the next video we will talk about, let's see what is there after that. Like we'll talk about light dependent resistors. So that'll be the next video. See you there.